What's going on, everybody? Today we're going to look at how I made a EDM drill head. It's electrical discharge machining, not EDM, not electronic dance music. I built it into my CNC machine. I needed to do this because I needed to drill some really high aspect ratio holes in Inconel. Let's see if we can see that. So I drilled all these. This material is notoriously difficult to machine, and I was drilling these initially. I was trying to do these traditionally with some really tiny drill bits. Really tiny drill bits, and that wasn't working. So I built an EDM machine into my CNC machine, and I'm gonna show you how I did it. All right, so I have the camera pointed down into the right side, so the machine is over, the CNC machine is over this way, and this is hanging off the edge of my machine. So I have some just wood struts kind of holding this onto some of the framing of this CNC machine. And before I talk about that, part of what's cool about EDM is it creates zero tool pressure. So this is an end mill. Let me focus on this. So this is an end mill. And if you are not super familiar with machining, this is it's tungsten carbide, so it's very hard. It's like the 5th hardest material in the world or something like that. So you make tools out of it so they can cut through anything. This would be essentially impossible to do any other way. So I drilled this hole. This is the rod that you actually use to do the EDM drilling, and then there's a tiny little hole through this rod that you use to flush dielectric through. So it's a fluid. In my case, it's an oil. Also, deionized water is often used. And this entire thing back here, for the most part, is for plumbing this fluid through. And I'm going to show how all this works. I'm going to start back here with the plumbing. So it's a little messy back here, and I apologize for that, but I want to show you how it actually is on the machine, because I got it tucked away and it actually works decently well. This is called the Hackbot, this machine. It's called that for a reason, but it does work. So to start off, there's a intake over in a vat of fluid over here, which I'll show you in a little bit, and that gets picked up by this low pressure pump. So that's sucking the fluid up, the dielectric fluid, the oil, and then it's coming off of it's coming in through here, and then it's coming out over here, and the outlet comes over into one of these two sides, this side right here. So it comes up and over into here, and then pumps through a filter, and that filters out the particulate from the EDM process. So essentially the metal is burning away as it does that, and it creates a very fine dust, and that'll clog up the tube that you're actually cutting doing the cutting with. It'll clog that up and probably cause other problems too, but that's the main problem. So you need to pump clean filtered fluid through this. These filters are apparently will clog up quite quickly because EDM makes a lot of dust. I haven't clogged one yet, but I also haven't done a ton of cutting with it yet. And you can see that it's pretty much black through here. You can't see through. When it started, it was clear. And then back behind that, it's really hard to see, but this thing back here is an airless paint sprayer. Sorry, I had to adjust the camera a little bit. This airless paint sprayer, this thing back here, that thing, is essentially, it's like a pressure washer essentially, but it just keeps I'm using it as a high pressure pump, so it goes up to 2,000 psi, and it comes out this blue tube right here, and it just turns on, and then when it gets below a certain amount, it turns back on. So comes up to a certain amount, turns off, and then the pressure drops, and then clicks back up. So it kind of pulses, and you'll see that during the cutting videos. That it pulses on and off as it's working. So then this blue tube comes out. So there's an inlet here, and then there's an outlet to this blue tube, and then there's another low pressure outlet too. So this high pressure, or this low pressure outlet right here, tees off. Half of it goes into the high pressure pump, and half of it comes back into the vat. And we'll get to the vat last. I'm gonna show you the cutting head next. Okay, so this is kind of the business end of this thing. So that blue high pressure line comes up through here. It's wrapping, so it's coming up through the drag line, this drag line right here, which is the stuff that moves, comes up, it moves and keeps things organized. You can't really see that, can you? This stuff, it moves and keeps tubes organized in CNC and other types of machines. So that comes up, and I just have, through the same drag line from my main machine, comes this tube. There we go. This tube comes up through here, and then it comes over into here, and then I have a valve right here that can be thrown on and off. When it's in the off position, it tends to get tangled when my machine homes, so I tend to just leave it open. But sometimes this thing leaks if you don't do this. So that turns off the high pressure line, and it comes into a T I made. By the way, the high pressure hose out of this, there's this fitting right back here, the main hose coming off. I could not figure out what that fitting was, so I had to weld it onto a piece of stainless steel that I tapped a 1/8 inch MPT to. So that's how I did that. I should say, this video is heavily inspired by Applied Science video on the same exact subject. What I think I've done is I've kind of tried to make it slightly more refined. This is definitely not like a professional machine, but it's a little bit more professional than what Applied Science did. And the reason for that is I'm trying to make some very specific parts in those in Inconel, like I was saying, out of this. So that's why this video exists. Is to try to show you how to potentially make a slightly more refined version of an EDM drill. But this video is a standalone video. You can definitely watch it and should be able to get everything, but you can also go watch his video as well. Anyway, I digress. High pressure fluid comes in here. Up here I have a way of measuring the pressures to keep an eye on it, and this mostly is showing me if the pump is actually, because sometimes these needles get clogged. If this is staying fixed, it shows me that it's not actually pumping through. So that's mostly what I use that for, and I use it a little bit to kind of gauge how much pressure I actually have. Okay, so and then that comes into this head, which I bought on AliExpress, and Applied Science talked about this a lot, but essentially they have more of these over in China for some reason. This is more popular in China, even though I think this is really a good thing to have in a machine shop. So you can buy this very cheap. This was like $100. It wasn't bad. I'm going to put links to a lot of the parts that I have in here. This thing spins this motor. Let me turn it on real quick. Okay, so you can see this is spinning here. Am I recording? I am recording. Okay, so you can see this is spinning. So the reason this is to keep a nice, super consistent cut. It's not like it's cutting with like flutes or anything like that, or actual like, it's not cutting like a drill bit would cut, but you want it to spin so it keeps a very consistent cut. So now what I'm gonna do is I'm gonna show you how, oh, another cool thing I think about my machine is that, I should say this, this is a Linux-based machine, so you could build this if you wanted to. That's a very important part of this entire video, is that you can go do this for like, I don't know, I think in total I put in like $1,500 in this, $1,200, something like that. You know, it's not nothing, but that's fairly doable. So I think that's pretty cool. I'm gonna talk about the power supply, which is over here, which I forgot to mention, but it's back over there. Let me talk about that real quick. So this is the power supply. Cooper from Rack Robotics sent this to me for free to try out for this video. He had seen my 5-axis video, and he's like, let me send you one of these. And this thing is awesome. This is really the star of this show. This thing is like, I think $400. So my cost did not include this. But this is really cool. Let me turn this off real quick. And so I set up some custom G-code to turn this on, to turn on a relay to turn on the pumps, and then also there's another signal that tells this to turn on and start cutting. So that's how this is all set up, and I'll get a shot of that to stick in. But this is really cool, and this, I think, the thing about Applied Sciences is that his power supply was like the backs, whatever it was, it's like a $2,000 power supply. It's not really something that just anyone can go and grab. This, anyone can just go and grab. So I'll put a link down this. They were having some problem with the V2. I think the V3 is out, so I think you can buy this, and I'm going to try to talk to Cooper and make sure that this is available for purchase as I'm making this video. And if it's not, I will get a link up to it where you can buy it anyway, because I think you really should if you're interested in this kind of thing. So this is pretty doable. Again, it's not free, but it's pretty doable. And I built mine into my own CNC machine. I'm not sure that was 100% the right move. If I was doing this again, I probably would build another machine out to do it. But what's nice about this is I didn't have to build another machine. I just built it into the machine I already had. And so to make that abundantly clear, this is a CNC spindle right here. So this is actually cutting with tungsten carbide a bit like this before it had the hole in it, and that's actually doing the cutting. So anyway, that was a bit of a digression. I apologize. Let's go back to this guy right here. So here is a chuck. It kind of sucks, but it's a Jacob's number 0 taper on here. I also got this from China, from AliExpress, I think. So this is the needle right here, and to put a new one of these in here, you have to put a a sleeve, or a, I don't know what you would call this, a washer, a seal, something like that. So essentially what you do is you grab a new tube, a new electrode, a new brass electrode. Brass is used because, I think because it burns down and dissolves effectively. So you put it in here, sticking out a little bit. Tighten it down. It's usually not going to be perfectly centered, and that's okay. I'll explain why in a second. Then you take the seal, the grommet, and that pops through, and it's usually like literally sealed, so you usually break the seal. This is an old one, so it didn't do that. And then you have to let's get the old one out. So I have to turn on the pump for half a second to get the old one out. So you heard me turn on the high pressure pump momentarily just to pop that out. And then I haven't talked about this yet, but this is the either the anode or the cathode, I can't remember. But this is forming the electrical signal, the positive, I believe, or is it the negative? I can't remember. But it's one half of the electrical leg coming to this. So this is just a piece of copper plate that's routed to here. I'll show how it's routed. But it has a bunch of holes in it for different diameters. So I stick the one in it that the diameter is, in this case 0.8, excuse me. Then I pop that up in there. And screw that in. And then it's a little bit long, so I usually trim it down here after I get it in because it creates a burr if you do it before. And it's hard to get through the holes. So we'll come back to the electrical routing to get this here. First, I'm going to finish showing you this. So in this 3D printed part right here is a bushing that has it's a bushing like this, and if you can tell that's pink right there. There's a sapphire, an artificial sapphire inside of this, and I think that's for low electrical conductivity, and I think it's also smooth, and it won't wear out, obviously, either. But there's a little sapphire in there, and that acts as a bushing and a guide. So this is really just driving, it's providing the high pressure fluid through that seal. So that seal has a shape like this on the inside, so the needle's going to the center, and so when fluid pushes into it, it pushes like this and creates the seal. So that's creating the seal, and then it's driving it around. So the high pressure fluid flows through, drives it around, do this. This is applying electricity, and then the bushing in here is keeping it concentric, and this is actually what keeps everything concentric. It actually gives you precision as you move. And this is fixed. This is on the z-axis, but it moves up and down. But this part right here stays fixed. It only moves with X and Y. And so what I found is that this thing it stays pretty tight, the needle. In fact, you can't see it moving at all. If the guide is close to the workpiece or close to the end of the electrode. But if it's sticking out a lot, it starts to wobble, and so what you get is you start to drill a hole much larger than you're trying to drill because this thing's wobbling around as you do it. So what I came up with is I have a, let me move the camera a little bit. What I have here is a linear rail from a 3D printer, from like I think a cheap resin printer, and then I have this 3D printed part on here that moves, has a stop right here, and it moves up and down. So I can drop this down to the exact location of my workpiece. So I can drop this down to the exact location of my workpiece like this, and then it's hitting on this. But I also have back here a stop that I printed, and the way I did this is let me pop this off and show it to you actually. So I think this is clever. So what I did is I copied into CAD the shape of the cross-sectional shape of the linear rail. I 3D printed this on a resin printer, and then I added some aluminum to both sides. One's just a through hole and one's a tapped hole. And then I made this on my lathe, and this tightens down, and it just works very well, and it just tightens down on the rail and works as a stop. And this way, I can get a nice repeatable use of the EDM. And this is very important for precision work, right? You want to take away as many variables as possible. So I can set the height where I want it, given the stop, and then I'll set the stop, let's say here, and then if I need to move this up to go zero this, so the way I zero this is my my probe just is electrical signal, so I put one side of my probe here and the other side is grounded to the machine. And then I can go probe the height, the Z height of this, and I can also probe an X and Y with this. And then if I need to move it around, I can move this up and down, and it'll go back to the stop in the same location every time. And that's really very nice, I think. Okay, these 3D prints, let's talk about those for a second. Prints were provided to me by the sponsor of this video, which is PCBWay. And I think they are really good, especially for certain people. So for me, I like owning all my tools and I like doing my own thing. Part of that's because I don't have a ton of cash to operate with. So if I'm going to invest money in something, I'd rather invest in the tools and then learn how to use the tools and do it myself. However, having gotten sponsored by PCBWay, I realize there's a nice niche for someone who maybe has a little bit more disposable income, not a lot. I mean, their parts are pretty darn cheap. They're very cost effective. But it's probably still cheaper to buy your own 3D printer. But if you don't want to do that, or you don't have time to do that, because this also takes time. So if you have a little bit more money than time, so maybe you're a little older, or maybe you don't want to fully invest in a 3D printer, I think this is awesome. I think they're a great company. They the parts get here pretty fast. I actually had to build 2 of these. The first one didn't work because it wasn't movable. It's something I realized after the fact. So this is the first piece that was just fixed, and so I wanted it to be able to move up and down. Just lost a screw in there. Also, these parts are super strong. This is a glass-filled nylon, and these parts are very, very strong. It's really cool. Usually, the parts arrive really quick. I had one order that took a little while to get here, but usually the turnaround time is really fast. So I think you can actually even use it for iteration and prototyping because you can get parts turned around. Is it quite as fast as having your own 3D printer? Maybe not, but it's still pretty awesome. And again, the quality is really high and the strength is really high. So yeah, thanks to PCBWay for making this video, because probably wouldn't be doing it without them. I don't know, I might be, but they're awesome. I like them. Go check them out if you're at all curious. Of course, they make PCBs as well, and I have a video coming out. My next video is going to be using some PCBs from PCBWay, but the 3D prints are really cool, and I think you should check them out. The next thing we're going to talk about is this vat right here, which I think is actually, maybe I should talk about this first, but I didn't. So this is cool. I like this. So this was initially for flood coolant for machining, and I'm going to build another one of these. I'm going to have 2 different loops, an EDM fluid and a machining fluid. Do not try to use machining fluid as EDM fluid. I tried that, and it burns up the oil. So I had to dump out all the oil and then get new oil, and that was a huge pain. So don't do that. So this is a 5-axis here. And the electrical connection, this is just a wire coming off, and I can, or 4th axis, excuse me. I can just take this and clip it on, and that is either the anode or the cathode, I can't remember, but that closes the electrical loop. And then this right here, this jaw is actually insulated via some fiber-filled plastic. There's a sheet in there, and then the bolts have some little insulated washers. So this is electrically isolated from the rest of the machine, which is very important. And this is the reason there's tape right here. Is right as I was finishing this video, I had a drill bit sitting here that shorted across this, and it fried the brain of my Linux CNC machines. This is the old fried one, so I had to go order a new one and put it in, which was kind of heartbreaking. But so this is really cool. So this allows me to do 4-axis drilling, which is something I need. If I don't want to do that, I can just put the material into this vat on an insulator and do it that, and then add this clip to it somehow. So that's really nice. This right here is ball of tape. By the way, electrical tape breaks down in this oil. It's really annoying, so I need a better solution for this. But I just have this taped around because I have some toroids to try to pick up some of the electrical noise that's given off by this high voltage signal. So there's a bunch of those everywhere, and I just have this one covered in tape. So what happens is this oil sits down the bottom of this tank, and then there's a pickup over here. So this piece of PVC has... Oh, this is going to be tricky. Hold on. So this piece of PVC, if you can see that, has some, like a prong cut into the end of that, and that's so it can't go all the way down. It's kind of, yeah, the height is sort of set perfectly, but it keeps it from going all the way down and plugging up. And then those little, the inside of the forks are set below the water or the fluid level. It's not water. And this oil is super thin. It's like the viscosity of water, but oil doesn't rust out parts and stuff, so it's a little better. So the intake comes up and then goes out to the low pressure pump, and then there's a return line for the low pressure pump right here, and there's also another return line. There's like a drainage out of the high pressure pump, so that just gets plumbed back in here too. The low pressure pump outlet comes to this piece of what is this, lock line, and floods the workpiece with dielectric to keep a spark from forming. So I'll turn this on real quick. Okay, and there you can see that the fluid is flowing, and then it's also adding that low pressure fluid to the high pressure pump to come out through here as well. So there's two fluid loops for this, and so this is really nice too. And I'm going to essentially do everything but the high pressure pump again. I'm going to have it hanging off the front of the machine, and that's going to be a really high quality cutting fluid. I think this vat, if you have a small machine like this vat is, it's 3D printed in metal. It's glued together, so the sides are metal, and then all the framing is done out of a 3D print. I think this is great if you're trying to do flood coolant on like a little gantry CNC machine like this, which a lot of people have these, but you can't do flood coolant. So if you need to do like a harder material, so I'm cutting Inconel on this machine, having flood coolant is pretty awesome. And then you obviously need it for the EDM as well. I'm gonna talk real quickly about a couple things I'd like to change. So here on this anode here, and I still need to show the plumbing for this, but I have this kind of pinned down with this. There's a spring, and this is 3D printed. This is all 3D printed by PCBWay, but this holds this down. I don't like this solution. It works fine with the 0.8 millimeter, which is the bigger hole I'm drilling. But this right here, which probably looks like I'm holding hair, but I'm not. I'm holding another electrode that does have a hole through it. This is 0.3, and I can push a 0.4, but I can't push a 0.3. And the reason I can't push a 0.3 is because of this. It gets caught, and then it just bends like this instead of going through the machine. Oh, we can't see that. So it bends like this instead of going through making it through this. And it's this part. This part is the problem. It's not a good solution. It puts too much force on it. So I want a way to ground it up higher to where it's moving with the Z. So if you do this, I would try to figure out a better solution than this. This is the same solution that Applied Science used, and I use, and it does work on the bigger parts. It doesn't work on the smaller parts. I can drill a 0.4 millimeter, but if you want to drill smaller than a 0.4, the stiffness of this in the Z direction starts to become a big problem. So keep that in mind. Okay, and the last thing I'll show here on the machine side is this is that drag line that I was telling you about. So I routed it separately, so you can see over here. I think you can see over here. Yeah, so there's to this hardboard, there's the anode and cathode coming out through here, and it splits in two directions. Okay, and then it runs up this piece of drag line. There's some 3D printed brackets. I printed these ones, not PCBWay. And then it comes down, and then this one, and rotates back up, and then comes out through here. And the reason for this, okay, and you can see, it's obviously sticking together, or sticking with the machine because of the drag line. And the reason this is routed separately from this is because, again, this is a very high voltage, and it gives off EMF that disrupts the electrical signals of the main machine. So that's why it's run differently, and it's running to the middle, and I had to modify this drag line to have a tighter bend and mess with it, but I got it working, and it works pretty well. Again, the only thing I wish is that this was actually going up and somehow connecting up at the top here, and I think that'd be a lot better. So figure out a way to do this if you do this yourself. That'd be my recommendation. Okay, the last thing I want to talk about here is I want to show you this. So what's cool about Linux is it's all based on Python, and using ChatGPT you're able to I was able to work with it fairly well, and so I was able to call in some Python scripts, and so I'm able to do things like, let's turn on this. Yeah, so you see that red light that came on? So that is tied into the enables on the power supply from Rack Robotics. So when that's on, that tells me this is dangerous and hot, so I don't grab both ends and kill myself in the shop. I think it's high enough voltage to do that, so I don't want to do that. And then I can just turn it off from here as well. And that's just some custom M code is what it's called. And the other thing I want to talk to you about is there's another signal coming off the Rack Robotics power supply that is, it claims to be duty cycle, but it's actually not a duty cycle. It's a pulse. It's essentially an analog signal coming off. And I had trouble reading it with the main board that is the Linux board. I tried for a while to get that board to read the signal, and I was just having trouble with it. So what I did is I just put an Arduino in the machine, and that is picking up an analog signal. And then if it gets over 80% duty cycle, so but in this case it's really an analog signal, it means that the electrode is starting to short between the two, and it's not cutting anymore, because the way this cuts, maybe I should have said this at the beginning, but the way this cuts is electricity is jumping back and forth between the spark gap, and it's burning away the material. So if there's not a spark gap there and it shorts, it doesn't cut, and it'll burn out the supply. So you need to be able to reverse the machine. So I look at this. If the signal goes over 80%, like 80% is the maximum, is the best area to be cutting, it throws a pin high and tells the machine, which throws a pin high, and then the Linux machine gets that pin, and then the code wasn't too hard to do. It just reverses the feed rate. So it reverses the feed rate, and then it goes away, and it's doing it for a couple more, like half a second, and then it comes back down. And it works really well. I tried initially, when I was having trouble, just lowering the feed rate down enough to where you could try to burn through. And it kind of worked a little bit, but it didn't work enough, especially when it's breaking through. It tends to short a little bit. So I was actually able to get almost all the way to the cut, just going really slow. It also eats up more of your electrode. It takes way longer, eats up more of your electrode, probably doesn't make as clean as the cut, and then will get stuck at the bottom. So it just doesn't work. You need some way to reverse the feed rate. It was tricky to do. It was kind of tricky to do. It wasn't that bad. I think that's it, guys. This is kind of a rambling video. Hopefully you're able to follow along. It's really cool. Being able to do this stuff is cool. If you're interested in doing something like this, I say go for it. Buy one of these EDM supplies from Rack Robotics. I want to support them. There's not a lot of good EDM power supplies in general, even less in the United States. I think it's really cool. I would like to see more people doing this kind of thing. They also have a wire EDM machine too, which is very cool. Check out PCBWay. They're awesome. Yeah. Bye, guys. Hey, I want to show you this outlet. There's a switch here that turns on the first one, and then this one's driven by a relay, only if the switch is also on. This is a high pressure pump in the EDM power supply, and then this one is always on. Also, I've heard you about the Howamat gear, and I'm gonna make a video on it. I've decided, just for you, because you all asked so many times. Comment down below, I read them. I don't respond to all of them, but I read them all. And subscribe to my channel. Bye.